Okay, now let's look at the problem. The problem is that this particular type function expands to looks like that. Okay, so that means that this expression is rewritten before the type function can execute, right? That is of course problematic because in a type function we are supposed to execute this while interpreting it, right? The way to fix this is by, let me make this a bit bigger. The way to fix this is by excluding that expression from semantic and rewriting it. And when we look at how the is expression is defined, we'll see that it contains of a type. That's the first thing in the is expression. Then comes an optional identifier, an optional token, and an optional tspec. So the thing we have here is actually that. Okay? That makes sense so far, right? However, inside this AST node, this thing is a type, which means it isn't possible for us to store a variable declaration in there, since that's a declaration, and we can't store a variable expression in there, since that's an expression. So what we'll have to do is we have to introduce a type that reflects an alias variable, or rather a type variable in this case. This should be relatively simple. There are many classes that are like that are not really things. So type instance has a template instance, type of has an expression in it, and we can just look at one of those type mixin. What's inside a type mixin? A type mixin has multiple expressions. We could use that. We could definitely use that. However, it isn't quite the right thing. We'd have to store a variable expression in there. So let's do something that is close to that, but doesn't require the problem. Okay. We just copy this, we paste it in, we say implement variable types, and call this one type variable. Inside the type variable there's just a variable declaration, like that. VD is just coming in DB-land. It says super T alias, because it is an alias variable or var declaration. I believe that's it. I mean, it's a type variable. That is what it is. Syntax copy would be type variable. Log and then bd syntax copy. There we go. 2D symbol. The 2D symbol, all this would do is return the variable declaration, I guess, because the variable declaration should be a symbol in itself. So the variable declaration. I mean, the variable declaration. What is it? It's a declaration, and declaration is derived from the symbol. So 2D symbol is literally just the return of VD. We have the visitor that accepts that, and I'm not sure if that thing is, no, this is not created from the class. So what I'll have to do is I'll have to add the type variable to that. Type mixin. So that is not in this visitor. It's probably in the past time visitor. It is not in the past time visitor. Like, are you kidding me? Then again, a type variable probably can't be visited, I would assume. Let's see if we can get away without adding anything here and see what we can do about this. So now that we have a type variable, we can go into the isExpression semantic and do something that's a bit neater as the thing we did before. We can go and resolve that, and if it is an expression, we do if res.exp is varexp. We can actually rewrite that to be a variable declaration. We can say type tr equals type variable of tr.log. It's a regular type, so it doesn't necessarily have a location, but you can always use e.log. Or probably ve.log, which would be the same location. And then we put ve.var.is var declaration in there. And we would assert that there actually is a var declaration in there. that, and we put it in there. And then, of course, request to allocate this thing. And if that has happened, then we say resolve true. Otherwise, we do this. Oh yeah, and we have to assert that the type of the expression has to be an alias type, so we do this. If res x and res x dot type is alias type, then we do this. Otherwise, we do if it is a type and res type if it is a type, we don't do anything, because the only point where we could reference to an alias is here. So yeah, that should probably work. And then we just do this, we print this out, so we know. Okay. This should actually do pretty much exactly what we wanted to do. Tab 2, 5, 10. Oh yes, missing multiple parameter. That has to be null. Constructor symbol what? Where? Or is that the super T alias constructor that is a problem? Okay, if I don't do that, I get no implicit match. I get that one. Constructor type variable this ref lock is not callable using argument. Could it be that this thing is called? Like from where? Okay, 5 to 10, that would be here. Oh, we forgot to cast to a var declaration, which we do need to do. Because syntax copy can't know. Now we do that. So now this compiles somewhat. And now we get an insertion in the header gen. Why? Simply because the header gen has no idea how to deal with a type variable expression. And why would it? That's easily fixable. Let me first look at the diff though. I want the addition of the type variable declaration to be relatively clean. So let me quickly go there. Here. Remove all those byte spaces. Okay, this is a bit better. Okay, now that we have the type variable and everything compiles, we can start and oh yes, we have to add support for that to the header gen type to buffer X. That's probably what I want to do now. So, no, I want to go to the header gen. There we go. Yeah, the thing is, yeah, alright. Let me just say alias return visit variable cast type variable t. We just follow the oh, okay, we have to say is type basic and not t dot ty equals t alias, because usually we count t alias as a basic type. However, in this case, well, it wouldn't be type basic, so never mind. That would actually not happen. So yeah, so that can be that. Void visit variable, we just follow the pattern set above. Actually, to like, I don't know what to write here. Declare to buffer. Is there a to buffer? There's a 2C buffer for variables, so I would say for declarations, so I'd say I can just do that. So I can just say tvd comma buff comma yeah, the symbol takes only the HDS. So we have the header join state, and we do that, and that's that. That would make that a thing. Okay. So we do get a variable expression. Indeed, this is good, which means we can go get the variable declaration from there and store that in the type variable. And we see that for a variable declaration, we do not have the 2C buffer. This is very strange to me. So what happens when we have a variable declaration? Like, and where is this one? And how would I trigger it? Oh, I just accept the t.vd since this is only a wrapper. So what I do is this. So t.vd.accept. That's all. This probably. That's all. Okay. Does this work? Okay, this dot accept. Accept. So that needs this. But so do I have to use symbol to buffer? Oh yeah, D symbol to buffer is what I have to do. This is so like this. That work? That so this calls D symbol to buffer. Alright, so I'm using that exactly in the same way that it's used in the template instances, but somehow this still fails. Okay, this fails because the variable declaration is null. Which you would expect that to fail, let's be honest. That makes no sense to me, as we know that at that point the variable should be set. Okay, so we go in here, we know that. We go in here and we make a new type variable with the variable declaration that is inside our so why if we go up what? No, don't terminate. So we go up, up. So before semantic, we're at 5396. Yeah, 5396, which is here. We have already put the type variable into arg and we know that variable declaration at that point when it is in the type variable, it cannot be null. So if we called toCars here, that will dispatch to the toCars for type variable, which uses the header gen the same way that we just did. We would expect this to succeed because we know that VD works. So we can say, and that is what we put in there, right? And the other one is talk. So if VD.toCars would fail, then we know that it's really null. But that shouldn't be happening. Okay. So VD.toCars doesn't fail. Unfortunately, printf doesn't. While it's within one printf, we can't see that. But if we now put this one here, then we should see that that one can be printed. And what we do is we put the same variable declaration inside the type variable. The only way that it could be null is if syntax copy sets it to null. Which may be happening. So, this variable declaration t is inside there, which makes me wonder why the type 2 buffer doesn't have it. So let's now check that targ.vd is set correctly. For that we have to say cast type variable targ and we know that that is what is in there. .vd.toCars. This will give us the variable declaration that is in targ right now, which may be null, which we suspect is null. Then we have to look at the constructor to find out what's going on. Yes, that is good, because that means we are not crazy. I am not sure exactly where this constructor is being called, but I could assume that variable declaration dot syntax copy is evoked. So let me remove the things from the printf here. And if we see the syntax copy being evoked, we know that that's a problem. And we see that that is not happening. We see that that is not happening, which means that somehow the constructor mustn't have gotten the variable declaration, but that's crazy. But I mean, alright, I mean, it's not like we can do anything about this, really, in any real way. Because we definitely need to make sure that the same variable... What the... Don't tell me this compiles. This variable declaration does not get stored in VD. Duh! Fail! This will fix it, guys. You can't... This is awesome. This is great. Yeah, so real good job, me. Yeah, sometimes so now we are a step better. Now t.vd will actually be set. Right? And for some reason the oh, I see what's going on here. Because we set the type to t_alias when when the pretty print visitor visits the variable declaration and it wants to print the type of that one, it will recurse into the thing that does the type variable. So that is an interesting dilemma. So that means we won't have the wrapper type variable that wraps a variable declaration, and we won't have t_alias that is the type of a type variable. That's interesting. I would say we just add a new type to type enum and be done with it. That should be what we should do, and that is what I will do right now. Type enum should be defined in here, right? Should be all in M type, right? Is it type enum type? I cannot. There we go. It's enum type, but we got it. So this is at the same place that a t mixin would be. It's just t variable, and we just add that. There we go. It is really not too bad. We just have to change this one into type variable, and the one that does t alias colon there was some switch which I just put in there. Alright, that switch was in the header gen. I remember. Yeah, that has now have to be a variable. T like that. Come on. So I didn't write that one correctly. It has to be t variable. And then try t variable like that. That now has to be that. Okay. That's completely reasonable. Where? In there. So now, this returns, and when we do the when we look at the generated stuff, I assume we still see the wrong thing, or maybe not. Test alias simple. -cg, and we see something interesting. We see yeah, it prints the whole it prints the variable declaration as is. So we see that there's actually a variable declaration to t in here. This is good. This is something that we can use to build upon. I'm not sure if I like how I handled printing of variable declarations. I would like it more if, because I just want to print out a reference to that actually. So maybe I start a var exp, because I actually want to refer to the expression. which I can trivially do, and maybe I'll just do that. Or I mean, visitor Vardecal. Yeah, so when we print that for that, then it just does vd ident2 string, and I assume we can just do the same thing if we wanted to. Yeah, so we could do that. How does it decide whether to put a semicolon behind it or not? Oh, it just writes a semicolon here, regardless. Yeah, so I guess we just say the ident string and we're done with that. I would say I think that's it, because that's how it should be. And now if we look at the generated code, it shouldn't be right. So that prints exactly what we want to see. We see after semantic has been executed an is expression with this variable inside, which is what we want. Since we do that, yeah, so since we hit a type variable, that will mean that we cannot actually keep that as is. So we have to do this pre-resolve flag setting thing. And yeah, but that works quite well. Like, that should work for alias variable declarations quite well. So yeah, I'd say this will enable us to be able to call this type function. So if we go to deinterpret.d, deinterpret will now see a new expression that it isn't that it is not used to seeing. Maybe we just put that under traits. Okay. I mean, we can just put it We just put it here. That is its expression. So what we do is we say auto targ equals CTV interpret e.d1 e.targ. Actually, we can't quite do that. We do another thing. We say, so when we hit this in CTV, the only thing that can happen is that we have a type variable. So we say type variable targ e.targ is type variable. We'll see that we don't have that. So how do we get it? The way we get it is we look for this is type D something, or is type predicate. We go where that's defined, and that has all these little thingies. We copy this one, and you can see the order in which those were added, by the way. Type traits are a bit newer than type mixin. This is the newest edition. This is we want to get out a type variable. The question we ask is this a type variable? And the identifier we check for is type variable. That's all there is to it. And now, I mean, we don't execute this type function yet, which means that this is never hid. So we said we have targ, and because the only is expression that we support for now is the one where we check if one type is a thing or it's not. We said that targ is set, and then we do say get value. So what we should get from here is a type expression. So targ v is a type variable. The actual targ is an expression which we get by getting the value of targ v. Right? Which is just get value of targ v dot vd. Okay? We assert that there is such a value, targ, and for now we just print that value, and that should be whatever t is. And then we just go like this, and of course we have to execute it now. Otherwise we won't see this. So let's just do it. Let's say pragma message is type int. And no, that should actually be parsable. Kind of. Oh no, it's not, because yeah. But we can ask if s1 is a type, and we have to declare s1. Here, just ask if it is a type, and we'll get an assertion failure in 6390 because we never set this thing. But what we get is that targ is indeed s1. So that means all we have to do now to get the result is to check if the expression we got back is a type expression. So we have bool is type equals expression targ is type exp. And if it is a type expression, then we return true. If it's not, we don't. So result equals create bool. There was some and create bool. That's the one where we just do is type, and that's that. That will create the boolean that we need. And that's all there is to implementing the single argument is expression. That's it. Oh yeah. Let's target. So yeah, right. That's all we need to do that. So we see that this returns true, and so let's maybe do pragma message is type hello. That should return false. And yeah, that's what we see. True, false. I am extremely amazed at how well this went. So and yeah, we are done with this, and the rest is going to be done offline.